Hi, I'm Jakub. You probably already know me. I hope some of you have been to my previous session. And today I will be talking about common mistakes in Pester tests. But first, I just want to say big thank you to all of you. Throughout the past days, I saw the awesome things that you do with Pester, and all of this stuff was really cool. And there were a lot of people talking with me on the corridors about what they do, what they use Pester for, and so on. So thank you. Give yourself a round of applause, please, because you totally deserve it. I wouldn't have thought like 5 years ago that we would have 700,000 downloads, we would be shipped with Windows and so on. So really, really awesome, and I still can't believe it. So my agenda is quite simple. I will show you stuff that I usually did myself, and then I learned from it, and I went on. So you don't have to repeat the same mistake. So I'm trying to save you some time. And what I will show you is not a prescription, it's just some suggestion of what you could do. And I will also show problems that others encounter quite commonly when I teach people about testing or introduce them to TDD. So that could help you as well. So hopefully it will make your test code better, and it will make your tests give you more value. Because in the end, it's about the tests helping you do what you want to do instead of you hating the tests for having more maintenance to do. So you have to decide what brings you the value and what does not. Sometimes people really struggle and they just say, well, I want to do testing, so I probably need to do TDD all the time, and they struggle with that and they really feel bad that they don't do TDD all the time, and I don't do that either. And then they realize, okay, we don't really have any use case for this, so we will just do environment checks, and that brings us value. That enables us to do the stuff that we want to do really quickly, really responsibly, and report to our managers and really see the value in what we're doing. So I will also go from actionable items to more abstract items to give you the things that you can change in your tests right away. And then we will maybe, if we have time, go through some other stuff that's more esoteric. So please, show of hands, who is not familiar with Pester, who is not using it at the moment. Okay, only a few. So let me just show you, walk you through like a typical test. So we have this function that's located in getPlanet.ps1. This is our production code. This is what we are developing. This is what we will probably ship in a module. And then we have this second file, getPlanet.tests.ps1, that Pester picks up and executes. And then we have 3 keywords, describe, it, and showed. So describe is a container for other describes or for it blocks. The it block is the next one. That's the test itself. That's what will become red or green at the end of the run. That's what will decide. That's what will show you if the test passed or not. And then we have the showed, which is a so-called assertion. And that will decide if the test will pass or it won't pass. Or maybe not exactly, but we will get into that. So first example is kind of a funny example, but I actually got sent code like this during a job interview from a senior developer. So maybe he wasn't writing tests before, ever, or maybe he was just trying to do something that really failed. And the test looked like this. So this is awesome thing because the test never fails. So you get a lot of value, ultimate tool to keep your management happy. All the tests are always green, or your builds are passing. You have a huge code coverage. You can ship directly to production all day, every day. Great, except the product doesn't work. But yeah, who cares about that? So it's not as great as I try to make it. So the test never fails. You have false sense of security, which is much worse than if you didn't have any tests at all, because then you have this huge list of green tests and your product doesn't work. So you think, oh, well, that's too bad. So why it doesn't fail? Because this is how an assertion looks like, and most of you probably knows it because you were in my previous session, but I cannot stress this out more. Assertions are just ifs and exceptions. There's no secret language between the framework and the assertion when the assertion would tell the framework, well, this test fails, so you fail as well. We don't need it because we have exceptions and those are universal. So whatever throws an exception fails the test. So just remember it and think about it this way. Otherwise, you will write reinforced tests. Solutions, just don't catch all exceptions inside of it. That's quite simple. And as I said, you don't have to do assertions with should. You can do it without. You can just write your own assertions. It's very simple. Or you can register it with the should. If you want to get more resources, then see the blog post that I'm linking. You can also see the assert module that I'm writing, where I'm kind of looking into what is possible, what we are doing wrong with the assertions in Pester, and trying to explore different ideas. So you can come over, send a PR, or help me, or give me an issue, because we first need to discuss it, and then we can port it back into Pester. And maybe the last one, if you're writing your own assertions, then it's very useful to have like very minimal set of assertions that you can use to test your assertions. So maybe read this, and if it makes sense, then let me know. If it doesn't, then let me know as well. I will be talking a lot about readability. So the first problem, we will go kind of from top to down, is non-descriptive test names. So this is always the case. Like test one, yeah, do something. Right, fails, that's awesome name for a test. Fails. Runs correctly, that's even better. Like, that's what we kind of want, like, make it run correctly, yeah? Negative values, positive values, empty file, wrong file, yeah, load file, so on. Returns result is great, or returns message, that happens a lot. Add 1 and 2, we're kind of getting there. Like, we actually know what it does, but we don't really know the result. So usually you're like, what? What's happening? Solutions for this, your test names should include what you're testing, what you expect the result to be. Simple as that. And you have the power to put as long descriptions to your tests as you can, unlike in C#, unfortunately. So use that power. Add spaces, add special characters, add all the stuff that you need to describe the test. Nobody will kill you if the description of the test is this big, if you need that information. And if you can, have a naming convention and use it. So sometimes I name tests like this. This is kind of shortened because I want it to fit on the slide. So I say, given 1 and 5, it returns 6. From that, you can guess that I'm probably writing like an addition function, like the canonical example of testing, probably. Given invalid password, it throws an unauthorized exception. That's great because you know there's a wrong password, this is the exception that we expect, this is what should happen. The last one is good. You can expand tokens inside of the name of the test. So then when you have a test cases, into which we will go in a second, then you get more descriptive test names. And it will show you the values that you are passing into the test. So then you can directly see on your build server what's happening. The goal of this is mainly if you run it on a build server and something fails, you don't want to go inside of your test suite, look at the code and try to figure out what's happening. You should be able to do it from the name and the failure message. Another one, unreadable tests. So when I joined one of my first projects, when I started being a developer, I inherited code base that had tests written in C# though, that looked like this. And there was like 3,000 of them, I think. Really good code coverage. nobody knew what the software does. So I looked at it and started digging in, and then I realized that it's totally crazy. It was like, having your software code and then having another batch of the same size of another software code, and then you should probably have the tests over it. And if you write it this way, then maybe another set of tests over it, and so on. So, yeah, it wasn't very useful. So problems with this one, you have no intent in the code. The code is too dry meaning don't repeat yourself, which is a principle that developers like to apply, but in this case you shouldn't. And to understand anything, you have to dig deep inside of the code, and you don't want to do that. You want to have 600 tests, look at them, look at each one of them, and understand what's happening right away. Not dig inside of each other, of the test, inside of the functions you have, and just to be able to find out what's happening. Another problem with this that might not be too obvious is that you share some data or you share some code base that will power your tests. And people usually see like, shared library or common library or something along those lines, and they think, where do I put it? So, well, I'll probably just put it inside of the shared library because everybody wants to have that. And so then you have your shared library with tons of code, and then you have some small pieces on the sides when the people didn't realize they can actually put it in shared library. So you have dependencies between your tests that you don't see, and people often just don't realize, if I add some code in here or some data into this set, then it might change all the tests that we already confirmed are correct. So I broke the test suite. Or I might not. That's even worse, because if it doesn't happen immediately, then you end up with a huge set of data that somehow works, and you still add to it until nobody knows what's happening, what was the original data for this test, and so on. So don't do it. So solutions, as I said, strive for readability, not dryness. In your test code, you can reuse the stuff that sets up your tests, but don't put the test data in it. Make them seeable inside of the body of the test. And you should also avoid parameters on those setup functions, because what happens is that the function then gets too wide. If you say, log me in as user, administrator, then you can put in any user. But if you write a function, log me in as administrator, you have only one option of what can happen. And if you control that, in the end, you might add log me in as normal user, but you don't want to give the power to the person who writes the tests to log in as any user, because then you get so much variation in your tests, and you don't want that. Because this was supposed to be, this function was supposed to be just your helper function to hide a bit of setup, and not a general function that you can reuse and reuse and reuse in multiple different places. So this would be an example of where I would apply this principle, but you can see that it's maybe too verbose, maybe too big. Like, I'm connecting to something, I'm giving it some password. If I have 200 tests, I will have to repeat this part. Sorry, I will show it on the slides, rather. So I would have to repeat this part in each of those tests. And I don't want to do that because that's just a setup for my test database. So why pollute the test? So instead of that, I would probably do it something like this. Expose the data, have the helper function set up the session for me. Now I can just go into it and just look at the test and just guess, well, yeah, it's calculating average in the cloud. I don't know why I would not do that this way. This one thing that people usually dismiss right away, but then they realize that it has some value. So if you make the AAA sections explicit, so you put the arrange, act, and assert in there in comments, then you can easily look at the test and you can see what you are trying to do. So if I write it this way and I go back to the test, I will first look at the assert part to see if there's anything interesting that I want to know, to see what the test actually does. or what's being tested. Then I look at this part, at the act part, to see what's being performed. And then probably, maybe sometimes, I look at this part where all the boring stuff is, where the mocks are, where the data are, and so on. So usually I don't have to look at this part at all. And the comments are very useful to split it into parts like this. And it's also great if you write bigger tests, which you will probably do, like integration tests, where this part could easily be like a range of some other test. We can, for example, see it here. So in some function, we would test create user. But in this case, we use the function that we already assume is working, the create user, to set up the test data for us. And if we didn't have the comments, it would be quite difficult to understand where the testing starts and where it doesn't, and where it ends. And you can also see that in this part, we have already an assertion. And so you can see it's in the arrange block, so it must be some kind of a guard assertion that helps us to set up the test and make sure that we have something to test. So if we didn't have this part here, or if it didn't work, then we would be able to pass the test, right? Because there would be no user, user would be null, we would pass the test, functionality wouldn't be there. Instead, we are creating the user first, then we make sure that the user exists. We add a because, and we explain we are doing this just to be able to, do the test, carry it out, so then when it fails on the build server, we can see it in the message and see, okay, this is a problem with the setup of the test, not problem of the functionality. So if we have a bigger problem with the functionality, we can just select the things that we want to include in our thinking, in our mind, instead of, seeing, yeah, deleting works, because we didn't have this assertion or anything. And so then you start reasoning about the code on false premise that the deleting works when it wasn't the case.
So this shows up in the output?
It does, yeah. Normally you get the message that says expected something but got something else. So this shows up in the middle. And it says expected something because but got something else. And you can include the because string in the string itself. So, but in the syntax, you would basically get doubled because, but internally we remove it if it's on the start.
There are two things in the same each block. So, for example, the first one is okay. So the create user is okay. What are the green, red part will appear in the test, or can it just be not that? The first one, the create user.
So.
Creation succeeds.
Oh, you're asking what would be the output? You would just get one result. It just, if this doesn't fail.
Repeat the question, please.
Yeah. So the question was what the output would be if we had two assertions, right? That's what you were asking? So the output would still be the same, because if this one doesn't fail, you don't get any output. So we just go forward, because we're not throwing any exception in this case. And then you would just get the normal output from this assertion, if there would be any, if it failed. And if it didn't, you would just get normal successful test case. So, anybody not familiar with test cases? Okay, good. I'm glad I included this slide. So, this is an example from the README that we have in Pester. And the test cases are really useful because they enable you to do data-driven tests. So you have this body of the test, and you can reuse it and test multiple different pairs of inputs over it without repeating the body multiple times. That helps you with maintenance, also helps you to easily extend the test cases that you are testing without copying too much code. So if you need to add another one, you just go here, add another pair like this, and you are testing a new thing, right? So this is really useful from testers' perspective. but not if you do it like this. And this is code from my framework, so yeah, I did most of the mistakes myself. So can anyone spot something that's odd? Apart from that it looks terrible. No, yeah, well, but you should. If you've been to Bartek's presentation, you would probably remember that if you take false string and you take false boolean and you compare them, you don't get true in PowerShell, you get false, right? So something must have happened here. Okay. Then there are probably some other edge cases. So how can we reason about that? Is that just a mistake in the test data? Is it something that we wanted? I don't know, and that's the problem. Your test cases grow and grow until nobody knows what's going on. Same problem like with sharing the data or sharing the test, the setup code for multiple tests. Solutions: split it into more tests with the same body and add the intent in the name of the test. That's one thing, but you will be repeating the same body of the test. Sometimes it's a good trade-off to make. You can add because string to the test case, and at the end in the hash table you will add like a because key and you will add the string, and then you will pass it in and you will plug it into the should. Or if you're just lazy, then at least split the test cases, add comments to them, so someone else who is not that lazy can refactor it later. So this would be probably how I would redo it if I would have to. And on the top you can see, sorry, I'll be showing it on the screen. On the top you can see that we are just normally comparing it. This is how PowerShell normally works. And then we say, given two values, left and right, that both implicitly cast to the same thing. Yeah, that's also how it works. And then we have these two values that are different, but are a special case that is fixed. Then it returns true, and then we can see this is the false. So I have the information. If I go into the test, I can understand what's happening. I can see this is not a mistake, this is a feature. And I made it much easier for me, or for the future people who will maintain my project. You have a question?
Yeah, is there an obvious way to know if I have come up all my edge cases and stuff like that, or is that part of the skill?
There is a reasonable way to do it, but the way... Oh yeah. If there is a reasonable way to know if I covered all my edge cases. So in normal unit testing, I don't think so, but there is a thing that's called property-based testing, where you use generators that generate different like edge cases or inputs to your test. And I'm sorry, then instead of writing the test, you are writing so-called properties that define how the thing should behave. So a canonical example of a property would be converting a string. Means that if you convert string one way and convert it the other way, you will get the original string. So you cannot prove that you actually did the work, but that's not the point. The point is to throw as many test cases on the thing to see what fails and then capture that inside of normal, typical unit tests. But there's no framework for that, I think, that I'm aware of. But we can write it together if you want. So, next problem. Too many assertions in your tests. So, who of you writes tests like this? Oh, not that many people. Interesting. So here we are just getting an object of a user, and then we check if all the properties are correct. The problem with this is that you get partial failure or partial information on failure. So if this fails on your build server, then you don't really know what's happening. And multiply this by thousands of tests, or maybe hundreds of tests that you have, and multiply it by, trying to fix the problem and getting different failures all the time. So if I just, don't get this first value, the name, correctly, it will fail there, but I fix it, so I go to the next place. But this is not the single place where the program fails. So other assertions are maybe ordered differently, so maybe they still fail the same way, maybe they fail differently. You just look at the output and you're like, yeah, what's happening, you know? Remember the girl? Exactly that happens. So we get seemingly random results as we progress to fix a bug. And the solutions to that, write more tests. Well, that's just too much work, and it's not very maintainable, because if I go to the object, I will add another property, then I won't be testing it because I didn't remember to go back to my tests and update them. So that really sucks. But a better solution would be if we could just take one object, another object, and just compare them, you know, the whole structure by values, and just go through the whole tree and do that. So I have a module for it that does that, but it's a bit experimental. So if you want to check it out, it's called Assert. And one of the features is this object equivalence that we can use. It works, I think, reasonably well for PowerShell objects, like the PS custom object. I mean, it doesn't work that well for stuff like system diagnostics process or something like that. But you can still do it, even with it. Then there's also this another concept of a compound assertion, where you pretty much do this, the same thing, but all the assertions will fail at the same time, or actually the output of all the assertions will be output at the end, so you run all of them and you only get the failures that fail. I'm sorry. So there are no very good solutions for this, but if you want to have good solutions, please join my project, use it in your project and let me know what fails. Generally, it should be working quite well. And so then you can either write your tests like this, or you can write it like this. So you just give it the expected object, you give it the result, you do assert equivalent over that, you see if the object's equal or not. This is very similar to fluent assertions in C# if anybody uses that. So I take the implement from them, which is an awesome collection of assertions. Yeah, and it's great for complement operations, for the operations like the inversion of string, but not just string, like something that you put on a server where it should be saved, and then you take it back, and you should get kind of the same object. Or you get a user, you update nothing, you save him, and you get the same thing, and then you just compare if the object is still the same. Or maybe you could just update one property, and then just update it back. That would make more sense, I guess. And this is how the compound assertion would look like, so same idea, but different syntax. Then this one, yeah. Using should not throw. So who uses should not throw here? Okay, no, you shouldn't be doing that. So the problem here is that the first test doesn't have any assertion in it. So you look at it and you say, okay, there's no assertion, how do I know it fails? So do I just want to execute it and then do nothing? That must pass, right? But if the test will if the code in the test will throw an exception, it will still fail the test, but we didn't test anything. So we just tested some code runs and does something, but we don't know what it does. So every line is kind of an implicit should not throw. We usually don't run code for it to do something. We run it to get some concrete result or some concrete action that happens. And so just testing if something happened, not something concrete happened, is a waste of our time. Because should not throw is a subset of every other correct validation. And the problem here is that this second test looks very complete. It has assertion, it does something, must be complete. Well, no, it's totally the same as the previous one. Because in both cases we just tested that the code executes correctly, but not that it produces the correct value. So,
but it's easier to read, or is it?
Well, I don't think so, because that's not a test that you should be writing. So I don't think there's any reasonable use case where you should be using it. If you think so, and I heard a lot of reasons, then let me know. I will be glad to learn about it. But for me, you just shouldn't use it ever, probably.
Yeah. I'm trying to import modules without getting any errors. Like when I'm dynamically generating module manifests and modules, and when this test, I need to test if it imports without throwing.
Okay. But then, if you import it, you want to start without the module, with the module not being imported, and add at a place where the module is imported. So that's something that you want to test. It's like if you flipped a switch on a light bulb, and you just tested that it flipped. But you want to know if the light is on or not, if the state changed. So if I flip a switch and the light is still on, and I flip it back and it's still on, what did I test? And if I don't look at the light, then I just flip the switch and nothing happens. So I think for every set operation, there should be a get operation, so you can validate what happened. So you get the side effect or the resulting value out of the action that you wanted to do. Does that make sense?
Yeah, well, if I make sure that this module is imported and then exported, and just make sure it doesn't throw. Same thing for like test module manifest. I just want to run test module manifest and make sure it passes.
Okay.
It doesn't return anything, so I could probably do it like it should be null.
Okay, yeah, we can. I still think you should validate something, because if you do an action and it doesn't produce anything or has no side effect, then you don't know if you did it or you didn't do it. So
if it doesn't occur, it succeeds. Yes. And if I have my code, I run all the tests on the code, and once all the tests is complete, I generate a module from the code. So I've already tested all my code in the modules. I don't care about like the code inside the modules, because I've already tested that. I would just want to test if I don't break anything when I come back into the module. So I guess I'm gonna make sure everything works.
okay, yeah, I'm pretty sure this is very like controversial topic, and maybe it's just the function itself that's written incorrectly. Maybe it should be producing the correct manifest, or maybe you can give it a pass-through and actually make it do the reasonable way of validating and returning you some value of like a true false or the body of the manifest or something. Because if it does nothing and you mock it with an empty function, it will still do the same thing. So you didn't prove that the function itself was actually executed and did something. Okay, so for me, the suggestion would be, if you write a test, start at the bottom. Think about what you want to do, and the because string is great for this because it forces you to think about what you're actually trying to do. And that way, you will have always an assertion in your tests, and you will be able to see what you're doing. So if you're testing something that outputs a value, test the value. If you test something that has a side effect, use assert mock called and test if it was executed correctly or called with the correct parameters. How are you doing on time? Oh, pretty good. So I think this is a proper test that we should be writing instead of just checking that add number doesn't throw. Another thing is not failing in an assertion. So sometimes people, and this was a part of a big blog on TDD, but this is the most important part that's applicable everywhere. So sometimes people write a test and it fails, it's red. So they just say, okay, it's red, now I'm just gonna go into my production code and I will fix it until the test is fixed. But they don't look at the place where the test failed. So if you don't fail inside of the assertion, you don't know if the test is actually testing the right thing. So if we throw before we test that our function that we give 10 and 10 returns 20, just because there was some problem, some other problem, and then we fix it, then we don't know if the test is correct. So always look if you fail in assertion, and if you do, then go and fix your function. If you're in doubt, you should think hard about the simplest way of failing the assertion in your test. Do the change inside of the production code, not in the test code. Make sure your test fails, return it back, and you should be golden. You just did like really quick red-green refactor cycle. So that concludes assertions, and now we go into logic in tests. And that's also a bit controversial, but it mainly comes from the early days of like writing OVF checks or environment validation, where people just threw code in the tests, and because it's a testing framework that runs the code, then it must be tested. Well, not true, right? Because you just use it as a code executor. And so we have this untested condition that's actually taken from the insights of Pester, so you can easily call me out on that. We do the same things inside of the framework as well, but we probably shouldn't. What we should do is, or maybe I will just go through the bad things first. Then we have conditional tests set up. I see people do that as well, so they put like an if inside of their code, and they do like, if we weren't able to connect to the database, then don't create the user.
So what if yeah, I'm the database guy, and if I'm starting off and moving through, describe through 100 servers, I want to say that there's no point in failing 100 tests, because if I know that if I've got that connected to the server, all 100 of those are going to fail. So just really one failure, don't carry all the way through. So I think there are some situations where that might be.
You are talking about this part, right?
Yeah. Well, what you in the end, see, I have it in the
Okay, I'm not sure if everybody can hear you. So the complaint was that if I'm setting up 100 tests, I don't want to run through the same failing action 100 times. Instead of that, I want to fail on the top. And I don't think this is the case, because this is inside of it. So we will get to the problem, and maybe then we can address yours. But I don't think you have any problem in that case. So the first problem is tests just contain untested logic, makes them complex. They might behave differently. You make a typo somewhere, you copy it incorrectly, then you get weird results. Would be much better if you just put it in a function. Then you have tests that do not fail fast, sorry. And so instead of failing in the setup of the test, you will go on and then you will fail in the act or assert part. And it will give you like a false result that will say your production code doesn't work, but instead the test is not set up correctly. And that's what you want to see. You want to make it fail as soon as possible with the correct error, instead of holding on and just checking, okay, we didn't set it up correctly, so we will fail somewhere in the bottom. So not a good thing to do. And then the loops that are empty. The problem is that if you have an empty test, then it passes. If you have an empty describe, it passes. If you take a loop and you generate the tests and you don't give it any data, you don't get any tests, and you pass. So if you do this and you just say, you know, here's a list of 60 audit items that we want to do on the database, and you make a typo and you don't give it any, then you get a passing test suite, and you might have like 1,000 items in it, so you just don't really notice that the 40 items are missing, but those were the really critical items. So solutions, put the conditions into functions when you can. We will address that also in the checking your or testing your tests that I will get to soon. Then let the test fail if it cannot set up. The test should fail because it couldn't do the thing that you wanted to do, so it should fail, not do conditions. And then you can protect the loop. So yeah, where is it? This one. So very easily you can just write assertion that just checks if there are items, and if there are, then it will just return the collection itself, and if they are not, then you will throw an exception that will fail your describe, and you will be much safer, because then the lack of data won't make your tests pass. You might not find it useful because, I don't know, you have something different, like a build pipeline that checks if we have 10% less tests than before, then we will fail anyway, or something like that. But it is good to be aware that if there are no data, then you might pass the test suite. And so if there's something that you really, really rely on, then make sure that you are putting the data in and that the tests are there. So usually this was called not testing your tests, but people usually find it very confusing. Why would I test my tests? That's why I write my tests, so they test my code. And I don't want to test my test, and it always, starts as a joke. People start asking me, are you testing your tests, and so on, and then we go into talk about cyclomatic complexities and stuff like that. It gets ugly really fast. And so I wrote a blog post where I'm addressing this. If you want to read it, it's probably much better than if I just quickly run through this. But the problem is like this. This is like an environmental validation check. It checks if I have at least 10% of disk space on my computer. And so you can see it's not very complex, but it's at least a bit complex. And the problem here is that you cannot really validate if this code is correct. So is here the guy who spots the typos really fast? Okay, yeah, who hasn't read the blog post? So if we run this code, and I actually should do this in a demo. So if we run this code, yeah, thank you. Nice. Run this code, the health check passes, I have enough space on my disk, so I'm happy about it. I can see, yeah, I've probably written it correctly. I don't want to go and just put, 10 gigs or 100 gigs of files on my disk just so I can check it if it works correctly, so I'm probably not going to do it. So, yeah, code looks correct, passes, I'll be happy with it, put it in production. But if I fix the typo, I can see that it doesn't pass. So which one is it? I don't know if there is a typo in my code and I cannot validate it, and there is no reasonable way for me that I would go through all the code and just search for all the problems. So what will happen is that I will deploy it somewhere. I will promise somebody that we will get alerts when there is too little space on the computers. And then probably some manager will be downloading some MP3s. And probably your manager, or maybe not, I don't know. I don't have that many managers who do that. But somebody high in the company will be doing something that they maybe shouldn't. They will run out of space, then they will call you and they will tell, well, you promised that there always will be 10% of space on my computer and that you will be notified. That will happen. Your manager will be angry because, you taunted this awesome environment validation to him, and he gave you 3 months to just investigate it and write the whole thing, and then it fails with this really bad error that would have been simple to avoid. So instead what I do is that I take this function, take the body of the test, and extract it into a function. And now what I can do is that I can take the function and test it, and then I can take the function and just put it inside of an it, and I would get pretty much the same thing. So I'll try that. Same code, still typo in place. Run the check, still passes, still 10% of free space available. So I write some tests for the code and run them. And then I see, okay, it doesn't throw when I have 1% of free disk space. That's very curious. That's not what I want. And this way, I can test that the code actually will do in production what it should do. Then when I apply it on the environment, I will get the correct results. Because now I can detect what's wrong. I don't have to guess. I can see that my test check is wrong and that I have a typo maybe somewhere or wrong logic. So I suggest you do it this way, like extract the body, test it, then run it inside of Pester, but just use it as a check runner, like a to-do list that will check off all the marks. Okay. So solutions, no solutions. Okay, now. Solutions, extract the bodies to functions, use the minimum amount of parameters for the functions that you extracted to make it still usable for you, but so you don't over-parameterize it. So just add the minimum amount of the function, so you don't have to write a new function, for 20% of free space or 30% of free space, but maybe on different disk. But just don't add too many parameters, because then you're again having a bigger chance of writing it incorrectly inside of the test body, and then again you have no idea if it works or if it's just your test code that's broken. So if you want to learn more about this, you can just read my blog post, give me some feedback. If you want, it should explain it in quite a lot of detail. Demo we went through. How much time do we have? 15 minutes? Okay. Can I do questions afterwards, or that includes it?
Oh no, that's the question.
Okay, yeah. So I will just quickly run through it because I was kind of prepared for this, not going inside of that. So I just quickly want to address in TDD. You write tests that immediately pass. You shouldn't be doing that. You edit test code and production code in the same step, so you have this red-green refactor cycle in which you should either edit test code or either edit the production code and then always rerun the test so you know where the problem is. If you don't do it, then you again don't know test code is broken or production code is broken, so don't do that. Don't fail in assertion, we already addressed that. And then you write no acceptance tests. That's something that happens quite often. You get caught up in functionality. You start, hacking away on it just to define an API that you cannot then use and build something bigger from it. So maybe think about it a bit more. Write a bigger test that will test the happy path of your code. Help you flesh out the API that you want to have, the names of the functions, the name of the parameters. You will see it all together, and then you can implement it, and then it will probably be much better for you than if you just applied TDD from the bottom all the time. You try fixing your tests without thinking. That would be a long discussion, but pretty much the TDD is think for you to help you understand the code that you're writing. So always think, will this test fail? With which error it will fail? Will it pass? What should I do next? If I change this value, will it fail this test? And if it doesn't, think about it, look in the code, and it will help you understand what's happening. And the last thing is you try to do TDD all the time, and I don't think that's something that you really should worry about, because a lot of people worry about I want to do testing, but I cannot bring myself to do TDD all the time, or I don't write any unit tests. You don't have to do it, it's just a methodology. And the TDD itself is just applicable only to problems that you kind of know how to solve, and you just need a ladder that you step on and go to the solution. If you need a breakthrough, then TDD won't help you. If you're solving something that's extremely simple, then TDD won't help you. It will probably be just too much complicated. So don't stress about it. Or if you want to learn more, you can talk to me later. And then the whole code structure, I will probably skip. One of the things that I just wanted to tell you is that try to extract your logic into pure functions. So into functions, into functions that take the input, pass out the output, and don't have any other side effects. If you do that, you have functions that are totally trivial to test because you just need to apply the test cases on them. And then you can think about it, and you can just have the mock on one side, which would be your output, and the output on this side. But if you have 20 mocks, then it gets more and more complicated. So if you can extract something into a pure function, where is it? And then you can organize the code to, get the data, do the logic, then set the data, then this logic for you will be quite easy to test. And you don't have to struggle with it that much. I would like to talk about that quite a lot, but we are running out of time. Sorry. So the ideal case, there is this abbreviation that's FIRST, which means that every test should be fast, isolated, repeatable, self-validating, and timely. So fast means it runs fast, isolated, it doesn't depend on any other test. Repeatable, you can run it as many times as you want. If you don't change the underlying thing, then it will be doing the same thing all the time. Self-validating, you shouldn't be clicking like a button or inputting something to a GUI when you run the test, so you can run it automatically without human intervention. And then timely, it should be written on time, so just write when you need it. For me in this, there are a few other attributes missing, like the test should be quite small, so you can understand it, you can put it on maybe one screen, but don't overdo it, do what works for you. It should be readable, it should be failing with a descriptive message, so when it fails on a build server, you get the idea of what happened. And then it should be failing in assertion most of the time, because that way you know that you're testing what you're testing. Summary, think about the next person that will be working on the project after you, or if you are an open source project, then think about the people that will try to get into that project, because they can go, they can read your its, describes, becauses, and all that stuff, and get an idea of why things work the way they work. Write a lot of pure functions if you can, because they are trivial to test. Review the error messages and all the other stuff before you just go inside of the code and start debugging, because that way you will make sure that your messages are informative. And if you can, and if you have this process in place, then get your test code reviewed. Complaining about others' code, people love to do it, so find someone who will do it as well. And yeah, keep it simple. That's it. Post me feedback on powershell.help if you can, please, and press the button on the door if you liked. So, questions, if we still have time? Okay, we have 5 minutes for questions. Okay, you?
So you showed us this delete user test, and what I was thinking is maybe you answered it already again, but if I have create user tests, should this thing, it will create user, check it, fail if it's wrong, but should this test also delete user and then fail? Because it should be somehow repeatable.
Okay. I will get back to it, and then I will repeat the question.
I stand it up that you will get.
Okay. Do you remember in which section it was? Because I don't. Okay, sorry. So I will just try to find it. This one. Was it this one? So your question was if a test for the create user function shouldn't delete the user as well? Personally, I would just throw away the whole database. I would create a new one for every test. Because then I get reasonably easy tests to write, and they are isolated. And if I can afford it, then time-wise, if I can afford that, every test running like 10 to 15 seconds, then I would do it this way, because then I don't have to worry about like, is this data here? Did this test change something else? But if I have read-only stuff, then I can, share it between a lot of tests, but I would just throw away the DB. Any other question?
What's the difference between the range and your before or?
I'm sorry?
What would be the different use case between your
Uh-huh.
and you're before all.
So the before all would set it up. Sorry, you should have spoken more loudly. So the question is, what's the difference between before all and arrange? So before all will set it up for just once for all the tests inside of the describe. If you would do before each, then they would be pretty much equivalent. But then you would be sharing the setup between all the it blocks that you have in the describe block. And if you don't need that, then it's better to have it in place so you can see what's happening. Yeah?
I also have a question. We had yesterday this demonstration by Rob, and he was showing us how to, let's say, fix some, I don't know, corner case that he found. But I'm not sure if I catched it correctly. How with this, let's say, mocking of the functions and catching these corner cases? If you mock something and then you presume some kind of result, then you will, in this mocking, actually skip these corner cases. So what is better suggestion, let's say, how to proceed with this mocking properly?
Okay, so the question is, how do I mock properly and still detect the edge cases at the same time? I don't think it's any different from doing it with the test cases. Unless you generate the data that are the edge case, or you get the data that are the edge case, then you don't have it, and there's pretty much nothing I can suggest you. Like, try to find it. It's a process, right? So you either have to think about the thing that should go wrong, capture the data, and put them inside of the mock, or you just have to append to the test cases as you go on and as you develop the product. Because there can be very strange bugs. Like, I talked about the property-based testing, and they used it against Dropbox to detect a problem that was 37 steps long with different actions, and then it resulted in a deleted file. You cannot reasonably think about that. But, you know, they automated it, used the property-based testing to do this. And if you thought about that, you would put it in your test cases, but I don't think you would, neither would I, or probably neither would anyone else. That's why the bug was in. So you just have to discover it, sorry. So, yeah?
You spoke a little bit on test-driven design and that you should maybe not always use test-driven design only. Could you say a little bit more about what would be a logical boundary way setting? From this point on, test-driven design would be useful, and before that point, well, not so much.
Okay, so personally, I use it in this way. I have, oh yeah, question. Repeat the question. When is TDD useful and when TDD is not useful? So for me, how I do it is if I get a problem that I don't know how to solve, I will solve it first and I will just write the function. I will implement it, I will throw a few test cases on it, and I will just try it out, you know, to see what will be needed to do, and I refine the idea, maybe prototype it really ugly, and then have the functionality that I want. And then I throw it away and I write it from the bottom up with TDD. If I want to be like evolving it more. So for example, about the assert module and the equivalence testing, I've written that over 2 hours, over some evening, just to try out the idea. It was really ugly and it kind of worked. But then I spent 3 months or 2 months over the evenings just writing the whole thing properly. So now just the assertion assertion module has more tests than Pester. So yeah. Basically, there's this like a Cinefin thing that says there is these things that are chaos and so on. But what comes out of that is if you need a breakthrough, then TDD won't help you. If you do something extremely simple, then TDD probably will complicate it for you. If you kind of know how to do it, or it's like a very simple thing to do but has quite a lot of edge cases that you need to cover, then TDD will probably help you because you will create the basic functionality and then you can add the edge cases on it so you make sure that they work. Okay, I have to cut it off. So thank you very much for coming. Thank you for using Pester. It was awesome.